Hello, everyone. Welcome to today's live stream event. My name is Tim. I'm with Reach the World. Hopefully you remember me from other Reach the World live stream events associated with the Endurance22 Expedition, during which a team of about 100 explorers and scientists located and mapped the wreck of the Endurance, Sir Ernest Shackleton's famous shipwreck at the bottom of the Weddell Sea. I'm very happy to welcome you back to another special live stream event with the Endurance22 Expedition. Our speaker today is the person who was the mastermind, and I hope you don't mind me describing you that way, Nico, the mastermind behind the plan to locate and map what was considered and still is considered the most challenging shipwreck in the world because of where it is. But I don't want to give too much away. We have Nico here with us live from Marseille today. So Nico, welcome to Reach the World.
Hey Tim, thank you to receive me tonight. I'm very happy to be there.
Absolutely, thank you. Thank you so much for joining us. I know you're staying up late to speak with our students today, and this is a really special opportunity. So I'm going to let you launch right into it. I'll bring up my slides if you want to start there, and then we can talk about who you are and what you did as part of this expedition.
Okay, so I was a subsea project manager for the Endurance22 expedition. My background is that I'm working on a special project for subsea activities since 30 years. I have been involved in several discoveries over the world, including Anton de Saint-Exupéry aircraft discovery in France in 2000, but as well most of the aircraft that we lost over the planet, like the AF447 Rio Paris or the MH370. I have been as well involved in the most deepest cargo recovered on seabed for Her Majesty the Queen of UK or United Kingdom. It was the shipwreck of city of Cairo, and we recover more than 100 tons of silver coins that we sent back to UK for Her Majesty. And my activities is most of the time to search what is lost at sea. So what makes Endurance world most challenging shipwreck? Frankly, Tim, look at your slide, and the answer is really on the questions. May I show you my little movie now?
Yeah, sure.
I would like to show it now. Let me try to share my screen. We made it just before together. Yes, to see it now.
Yeah, there we go. Let's bring it up here. There you go.
So I made this little movie sense of all the nice videos that our media, nice people made on board the vessel. And to respond to your questions is look at the weather condition here. Most of the time when you're doing subsea activities on open water, you have the opportunities to be quite free on your operations. Here it was the opposite, and this is the opposite. And this is what is the most challenging for subsea activities. Normally when you work on subsea, your vehicle, which is underwater, is becoming the master, and anything which is on the surface is your slave. Here the master was the ice, and you got no opportunity to drive anything. You was just living and suffering the ice. And the other things which was extremely challenging is to find a way to come back on this very, very small area which is behind the vessel. And that's really, really something important to mention, because we got from time to time the vehicle more than 4 to 5 nautical miles from the vessel, and we have to come back to this very, very small area which is behind the vessel. So believe me, your technology have to be ready, and you have to be really, really sure that you will be able to come back here. And this all a question of drift. And the Shackleton story, it's a question of drift, if you agreed with me, Tim. And because this vessel was stuck in ice and drift with ice during months and months and months. And the subsea operation here is the same. They have been led by drift. And if you do not consider drift on this project, you lost. And
It's worth pausing for a moment for people who are not as familiar with the Weddell Sea to note that the ice on top of the Weddell Sea is always moving, and sometimes moving very quickly in unpredictable ways.
that's a good point that you mentioned that, because we got drift speed up to 0.7 knots, which means that when you have a dive which is 10 hours, you have drifted by 7 nautical miles. You are 7 nautical miles from your launch point, so you have to be ready to recover on a position which is unpredictable and more than 7 miles from your launch point. And usually when you do subsea operation with AUV on open water, you know precisely when you launch, and you know precisely where. Oh, sorry, there is some sounds here. I stopped that, and sorry for that. And you know precisely when you will recover. And in Weddell Sea, it's always unpredictable.
Yeah.
And the drift forecast that we got from Germany and from the scientists in Germany has been really a game changer to allow nice operations.
Okay, so to summarize, it's getting to the site itself. It's the harsh environment of the Weddell Sea. We haven't gotten too much into what it's like at the bottom of the Weddell Sea, underneath 2 miles of water, but we'll get there. I think people get the idea. It's a very, very challenging place to conduct subsea operations. I know that lots of people have described this as a very impossible challenge, right? Like, don't go after endurance. It's impossible to get to. But you were the one who was tasked with doing the impossible. How did you approach this impossible challenge?
Well, we try to be ready for any case scenario. And I think that the lesson learned from the Weddell Sea expedition, which has been made in 2019, has been very helpful for us, because we worked over 2 years to be ready at any case scenario, even the worst one, which was to launch from the ice. And that's the reason why you saw that slide, because in case we were in the position that you need to launch from ice, all our stuff was ready to be flight by helicopter, but helicopter can only carry out 1.5 ton weight. So all our devices was set for 1.5 ton weight. And you have to keep in mind that when you have a vehicle itself, which is 1.7 ton weight, you need devices which are heavy to manage it. So it has been quite challenging, and we work on procedures, we work on worst case scenario, we work on risk assessment, and it is all this work which has been made during months and months and months to be ready that is making the impossible possible. And it has been a very long job in engineering and in project management over these years.
Can you tell us what's happening in this picture?
Oh, yes. These pictures is a trials that we made in France. In fact, during the preparation of the Endurance22, we got 6 months preparation from September 21 to January 22. And one of these trials was in France, where we simulate the ice camp by using a barge. So here you have a barge with a moon pool, and we built the launch and recovery system, ice launch and recovery system, which was ready for ice to be used from the ice. So here we are simulating a launch and recovery of the vehicle. And the reason why the vehicle is vertical, because as you can see, it's vertical launch, it's because it was, as you can see, it's a rectangle. And to launch it on the horizontal whale, it's generated to build a huge pool on the ice. So that means to drilling a huge huge pool and it was taking a lot of time. So we make the decision to make a small hole and to launch it vertically. But to launch it vertically, that means that you have a 1.7 ton vehicle that you have to lift at 2 meter high, put it vertical, and to launch it. It's like if I do it with your car, Tim. I think that most of people have a car which is roughly less than 2 tons. Okay, and so imagine that I take your car, I lift it safely without damage it at 1.5 to 2 meter high, move it vertical and launch it. And then I have to recover it on the same way and put it back horizontal to put it back on ice. It has been quite challenging and a lot of work. So your pictures here is showing the trials that we made in France. It was working quite well.
Very good. I know there was a lot of preparation before we got anywhere near the Weddell Sea. By the time we got to the dockside in Cape Town, I arrived just in time to see some really interesting things being loaded into the hold of the SA Agulhas II. What are some of the things that you sort of, what I see here are creative solutions to the problems that you expected to face in the Weddell Sea. Can you point out a couple of the things on the deck here that you created?
May I show you some my screen, Owen?
Yeah, sure.
So sorry, I have to share it again. So, do you see my screen?
Yep, there it is.
So, it's some pics I would like to show you. It's all of this is starting to be real in Motola in Sweden. Okay, so if we go really back in the past, we start in September 2020, and we launch the decision to choose the Sabertooth, and from September 2020 to September 2021. In fact, during a year, we will be doing engineering, build procedures, and make everything ready for the expedition. I like to say that it's like going in the moon. You know, Tim, most probably heard me to tell that already. It's I mean, you need to build the rocket, compute the trajectory to safely land on the moon, and the moon of the Endurance 22 was in the wreck of the Endurance, and it's precisely like this. And you have to anticipate everything. So this first pictures is a final acceptance test of the two vehicles in Sweden in Saab facilities, and there is a lot of works and a lot of skills for plenty people to allow that to working, because when something is working easily, everybody thinks is easy. But you have a lot of students here which are doing robots, underwater robots, and they know that there is a lot of skills that you require to do that properly. And it's not only electronics as you do here, but is as well mechanics, okay, to not break you. And there is as well some good ideas and some engineering. The reason why I'm showing you that, I will explain you later. It's this vehicle was tethered. You remember that? And how you protect a 3 millimeters diameter, very small tether from the ice. And this idea was a game changer for us, because we started to build very strong frame behind the vessel to try to protect the tether. And it was each time the wrong way. So finally, I just suggested to the engineering team, why you do not build simply a fishing float? Because when you have a fishing float in your river, when you have an obstacle, the fishing float is just moving up and down. And if we have ice, it will be the same. So it's what we done, and it has worked quite cleverly. Then wiring. It's interesting to explain to the people that doing subsea operation is not only high-level engineering, it's as well basic work. Here, this guy is one of my most famous survey engineer, and look at it. He's just doing basic works of wiring, because if he do not it himself, he's not sure that it will as he want. And as just said, it's as well very simple job. The shipment is always a nightmare, more especially when you are in a over the world during COVID pandemic, which is generating drama. So believe me, Endurance22 has been a nightmare with shipment over the world. But I just explain to you on the way how to find any solutions. It was on the slide before.
Yeah.
The device that you're seeing here, it's a way to drill the ice. And again, it has been the trials in France. I still try to reply to your question, how I prepare everything. That I would like to explain to everybody. It's you have several variables, and you have to be ready to reply at any questions if you want to arrive at your goal. Okay, and you need to have several skills on project management, which is extremely high. So trials in France. A lesson learned from the Weddell Sea expedition in 2019 has been that we need to arrive in Antarctica with all equipment calibrated, because calibration is required when you want to do some data. And as well, you need to test all the equipment. So we came in France and we make trials at 2,700 meter depth, because depth on Weddell Sea, if you remember, is 3,000. So we were almost ready at max depth. And we got, again, a lot of issues. It's never working the first time. So you see the team here, they have all open again the vehicle on the top of the back deck of the vessel and working again on sorting out all issues. Days and night, you never stop. Okay, and it's never stopping.
Nico, one of the things I appreciate about you and your colleagues is that you're very open about talking about how challenging it is to work in these environments, and that things don't always go right for you, even though you are at the top of your game for marine robotics and underwater searching, that even the professionals have, things go wrong, you're replacing parts, you're troubleshooting things, and it's all part of the testing process for being ready to complete the mission.
Thank you. Yeah, I appreciate that. I appreciate that, your comment, because this is really a part of our way to think. I mean, if you want to be sure to be ready to success your next dive, you have to have this open mind and ready to face any kind of situations at any time. And this is precisely what made the team and that you met on board the vessel. They are ready for that. They have been trained for that, and they are really good for that. Right. And so trials again and issues again. If you remember, team, we broke in Antarctica quite a few times the umbilical, but it's not so much times, because we have trials, everything in France, and we know what to do and not what to do. So it has been quite helpful to do these trials.
Nico, let me interrupt for a second and ask a question that's in the chat, specifically about the tether, because the tether is a really interesting thing all in of itself. We have a question from Barb in the chat. She wants to know how much fiber optic cable was deployed while the AUVs were out, and also, was the fiber optic cable armored, and did it carry power?
Okay, so we deployed up to 8 kilometers of tether during the project, due to the reason why we drift so much, as I explained before. And the purpose of the tether was only to carry out data. And the reason of that is there is several reasons of that. Why only data, and why tether? Tether, because a lesson learned from 2019 has been that under ice, you cannot anticipate what can be a condition. And usually when you have an autonomous underwater vehicle, when you have any issue, you do an emergency ascent. And if you are in open water, it's just coming in surface and just scream to his iridium beacon, hey, recover me, I'm here. But when you are on the ice, if the vehicle is doing an emergency ascent that you do not control, you lose it. So the reason why we got tethered is to have a real-time connection, even if it is an underwater autonomous vehicle, because we want to be sure that at the first second that we have an issue, we have the control on it. And it gave us the opportunity as well to have real-time data, because usually when you have an AUV, you have to need that vehicle is coming back on deck to recover the data. Here, we got the opportunity to have it straight away. And about the typical cables that we used, it was only a fiber optic, no wire, and no copper, and no power. And the reason of that is because to power a vehicle like this, you will require so much copper that the size of the cable will become quite big, and the drags that you will generate it at that depth and that length will be not manageable by the vehicle. It will burn the power to go so deep, and you will have a huge winch on the back deck. You imagine 8 kilometers of most probably I don't know, 18 to 22 millimeter diameter cable. It will be huge. So here we make the decision to have only data through a fiber optic, which is protected by a Kevlar to respond to all the questions.
Very good. I'm keeping an eye on time, and I want to jump back to sort of the live expedition, so we make sure we get a chance to go to our classrooms who are here watching. I thought it would be a really good for you to describe what a typical day was like on the aft deck of the SA Gauls 2 while you were searching for Endurance.
Well, you have to be aware that on a subsea operation, we work 24/7. Okay, and whatever is the condition and whatever is the weather. So we got a team organized to make shift from midnight to midday and from midday to midnight. But unfortunately, when you have some issues, people cannot go to rest. They have to stay because we need them. And you suffer that with us at the beginning of the first days. We got a lot of issues, if you remember, more especially with the winches, and people work it from time to time 18, 19 hours, just have 1 hour sleep and came back. And it was mandatory to be sure that the project is a success. So the typical day, and at the beginning is always quite complicated, and then the routine starts and it's working quite better and better. And on Endurance 22, due to the conditions that we got on site and due to the condition of the vehicle, we made dives which were roughly 10 hours, and then we got a recharge of 3 hours. So roughly we got a cycle of 12 hours to be ready for the next dive, and it was the time that required as well the vessel to move on ice, and it's something that we may talk about quite a long time as well, Tim. You remember moving the vessel? This vessel was absolutely great. Can you remember that? When she crashed the ice, she was absolutely great, and she was able to steam at more than 10 knots over 3 meter ice thickness, and to reach the next position. I never saw that before in my life. And we got here again the game changer by the satellite images coming from Germany, and the drift forecast, which was allowing us to choose where will be the next dive. And it was really important to optimize the time. When I came on the transit, you remember we got that chat when I said we are on a countdown to success or failure over the times that we have on site. And frankly, fighting for each second was for me my primary task. And this vessel has been marvelous to manage each ship movement from the next to the next dive, as well, thanks to the ice pilot and his management of the ship movement. So yeah, it was roughly the normal time. So you recover the vehicle, you do maintenance, you recharge, and you wait to be on the next position, you redive, you go the descent. Keep in mind, this vehicle have 6 degrees of freedom. You can dive vertically like this, very fast. And then the team starting the survey. This is a survey pattern based on the condition on site. And then again, we recover maintenance, recharge, next dive, blah, 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 blah.
Great. Yeah, let me show this picture because this is what the back deck looked like most often when the AUV was underwater scouring the seabed. This is what we just saw a picture of the fishing float here. And can you just sort of describe what we're looking at here?
Yeah. So that's a typical dive here. I explained just before how this device is working. So, and you saw it to be launched over my small movie. This device has been really a game changer for us because it allows us to have our tether always protected against ice, but as well against for the propeller. You have to remember that if this vessel is able to go in through ice, which is 3 meter thickness at 10 knots, that means that she's quite powerful, and she can swallow a 3.5 millimeters tether quite easily. So this device was allowing us to be quite safe from the propeller as well, and during the full dive. And it has been really a good device that helped us quite a lot.
For sure. Let me fast forward if I can, because all of these efforts led to the discovery of the Endurance itself. And that wasn't the end of the mission. Like, a lot had to happen as soon as you and the subsea team found Endurance. Can you describe sort of how you felt when you saw it for the first time? And then I think the next slide is, what did you do next? What was the mapping and scanning process like?
Well, a lot of relief and a lot of a sense of achievement, and quite a lot of pride of my team. Achievement because it was 3 years work for me to access to that. And when you see her the first time, you say, you made it, guys. And you remember my comment before? I said how to land on the moon. So we land here we are landing on the moon, and every people is safe on the moon. So you say, wow, that's quite an achievement. And I think that most probably Shackleton will have this achievement when he recovered all his guys, remember, on the Elephant Island, after all these months when they were alone waiting for him. And when he came back and recovered all his guys, most probably it was an achievement for him. And believe me, seeing the Endurance has been an achievement for me.
For sure. This is just another photo of the wreck that the Sabertooth took. Can you describe real briefly the process of surveying and mapping Endurance?
Yes. So may I show you my screen as well, or we are too late?
Yeah, no, let's move it to yours.
Okay. So what do you think? The Sabertooth was fitted in 2 ways: in survey mode or in inspection mode. In survey mode, the primary sensor was side scan sonar with very low frequency, and it was a triple frequency, allowing to make a good signature of the wreck. What you're seeing here is the first hit in low frequency. So don't tell to anybody that I show it to you. So it's the first hit in low frequency, and believe me, there is people which are extremely skilled to understand that it is precisely what we are looking for. So in inspection mode, we got side scan sonar, multi-beam, and then we switch it to inspection mode with 4K camera, still camera, and 4K. And laser 3D. So this is high frequency sonar now, when you can see more precisely the wreck and the score which is around. And this is multi-beam data. So to make that, you have the vehicle which is required to fly on the top of the wreck. And this is precisely what the people is doing here, because you're asking me how it's working. So the guys is working on a survey pattern that you are looking at, a task plan, which is then sent to the top side of the vehicle, allowing it to follow a precise survey planning and survey routing, allowing to make all this data properly, okay, and to produce the final kind of data that you can see here. Okay,
beautiful.
I insist to show that these guys, these people, they are magic, because doing all of this, it's impossible to do it alone. You need great people, and I like to say that even the Captain Kirk cannot go to the final frontier alone. You need a crew, and we have been on the final frontier in Weddell Sea, and these guys, it has been quite marvelous to do it, and they make an absolute great job, and I really, really, really thank them. I'm very proud about them.
Awesome. Well, thank you, Nico, for showing us those pictures. I will never get tired of looking at the sonar and mapping data from the ship. It's so beautiful to see. We have 2 marine robotics teams joining us from New Jersey today. I'd love to give them a chance to ask you their questions. So I'm going to start by bringing on the HMS Seabots, who are joining us from Harrington Middle School in Mount Laurel, New Jersey. Hey, Seabots, how you doing today?
Good.
Great to see you.
Hey.
Do you want to go ahead and ask Nico Vincent one of your questions?
Make sure and get in the mic. Good.
So our team is keen on time management. So I was wondering, after 2 years of planning, how long were the AUVs launched in the Weddell Sea to find the Endurance?
We required initially 12 days to doing that job, but believe me, I was quite sure that 12 days was not enough, and finally we got an extension of 10 days, and 3 days before the end, so at day 19, sorry, we got a hit. So it has been required 19 days on site to discover the Endurance.
Thank you so much.
Welcome.
Well, we have you on the screen. Do you want to ask a second question?
As a software engineer and co-pilot, I found that integrating our camera and gripper system was very challenging. So this made me wonder, what was the most difficult part of building your AUV and ROV?
It's interesting questions. Usually the manufacturer of vehicle, they offer you a package. They offer you a package which is a vehicle itself, which is also control system, is topside system, is a task plan system, and in addition, as a client to them, you add the payload that you want. On Endurance 22, one of the challenging things is that for the broadcast, we asked it to add a 4K camera, for example, to respond to your questions. And this 4K camera was not going through the Saab system. It was a special payload which require a lot of the data consumption, because 4K is very huge volume of data. So you need to have special link in the fiber optic for that. And usually this is manufacturer which is allowing you slot for your payloads, and they are what we call payload area or survey area, that allowing you to choose your own devices that you want to connect. It can be a camera, as you asked, or it can be something else. It can be a multi-beam. It can be a side scan sonar. And because from the bottom to the surface, anyway, it's becoming data. Okay. So I do not know if I replied properly to your question, but usually you have a volume of data, and you connect the data on the bottom and you recover this data on the surface.
It's probably helpful to add too that there were engineers from Saab on the expedition who were helping to look at their systems as well. Like they were part of the team as well, right?
That's true, Tim. But to be frank with you, on Endurance 22, we got more issues with software, which was unexpected, than the hardware. And fortunately, we got both engineers from Saab, one for the hardware and one for the software. And we got more issue on the software than the hardware.
All right, thank you. HMS Seabots, we'll come back to you in just a second. I want to bring in the Mount Olive High School Marine Robotics team. Hey, Mount Olive, how you doing? Welcome.
Hello.
Go ahead and ask your question, please.
So we had 2 quick questions. First off, what sort of prototyping did you use? Did you begin with that final AUV, or did you have like some smaller scale ones that you worked with in advance?
No, we use straight away the Sabertooth. You have to be aware that the Sabertooth is a standard product in the industry. Okay, I'm not sure about what I'm saying, but I think that the one that we got is number 22. I'm not sure about what I'm saying. During the year of preparation, we on the engineering preparation with the people of Saab, we anticipated all the requirement, all the specification of the vehicle to be ready for the factory acceptance test. And when we arrived in September 21, in theory, they were ready to launch the vehicle, show that the vehicle is responding to the specification, and then show that it can accept and manage our payloads. And it has been not completely positive, but it has been good enough. So we haven't been obliged to going through a prototype because the vehicle is already something which is on the shelves on the industry. And however, we pushed the vehicle quite a lot because before Endurance22, this series never gone so deep. This series I've never launched so much tether. And this series never been so far away from a vessel. So we got some unexpectation, which was close to the consequences of a prototype. But you know what we say in subsea industry that when you do one vehicle of it's a prototype. When you do 2 vehicle identical, it's a huge series. And because even on a series, vehicle are never identical. And we got on Endurance22 2 vehicle which have been built with 1 year difference, and it has been very complicated to have them strictly identical as we require. So no prototype, but prototype effect.
Yeah, thank you, Nico. Mount Olive, do you have another question you'd like to ask? Go ahead.
We also wanted to know, you were talking about how you added on a camera after the fact and how you added certain functionality, but was there anything you wanted the Sabertooth to do that you weren't able to accomplish at the end?
No, we have been quite happy, to be frank. That's a good point that you mentioned the 4K. Again, as I mentioned to the other school class, it has been the most complicated devices to interface due to the volume of data that require 4K. So the optical volume of data was huge, and Saab managed it quite well. But the reason why we haven't suffered a lot of issues on payload interface is because on this project it has been appointed a lot of time for trials, and believe me, it has been again one of the game changer. What was not working in Motala in Sweden have been then double check in France, and what was not working in France has been again to check again on the barge to finally be ready when we join Antarctica. So we got a lot of time, which is quite unusual in the industry. Usually, when you have a project like this, you have few weeks or even only few days to be ready. For Endurance22, we got the opportunity to have a lot of time, and it was necessary to avoid all this prototype effect that you just mentioned on your question before. It has been very as well helpful to avoid a lot of issues on site. And it has been a lesson learned from Weddell Sea Expedition 2019, where they suffer the opposite. A lot of issues because they came without trials, without at all trials. They made no trials, and finally suffer failure after failure after failure. And but when you come in Antarctica, you have no choice. You have to be ready. Otherwise, you go to failure. If you want to a success, you have to leave. You have to leave shore with a system which is 100% tested and approved.
Great question. Great answer. Thank you, Nico. Thank you, Mount Olive. We'll come back to you for some more questions in a minute if you have some more. But for now, I'm going to take you off screen and bring the HMS Seabots back. Hey, HMS Seabots, do you have some more questions you'd like to ask Nico?
So I joined the HMS Seabots because I've always been interested with the field of engineering. So my question would be, what is your background education? How did you get into ocean research?
Unfortunately, I have an unusual background because I made my school time in France, and after my high school, I chose a dedicated subsea solution, but it was short time, and I have been during my internship. I have been, in fact, straight away employed by the company, which was where I was doing my internship, and I finished my studies inside the company, and at that time the company was the most important one in the world. And after a couple of years, not couple, 5 years, I become the manager of my own department, subsea department, outside oil and gas. So I was already in charge of all activities for navies and special projects. So I'm afraid that I'm not the best one to advise you on the best way to become a good subsea engineer, because I'm unfortunately old enough to have been teached on the company that was employing me. Sorry for that.
You know, Nico, I had a chance to talk to a lot of your team on the ship, and I asked them how they became involved in the subsea industry, and many of them had gone to the same school in France that specialized in this kind of work. So sometimes I think there are institutions that specialize in this field of study. Especially, I would imagine marine engineering is its own thing that this young man may be interested in checking out.
I ignore if in US you have some subsea engineering high school, but there is, I think in France, in my country, there is a single one. And there is another school that you mentioned that my team have made most of them, which is in joint venture with an high school in Wales, in UK. And but this is really quite unusual. I don't know in your country. I'm sorry to be not.
That's okay.
Not very...
I know that by participating in marine robotics competitions, you're already ahead of the game for a lot of young people who are interested in that career. So I'd encourage you to keep it up. Good work. Any other questions from the HMS Seabots before we switch back to Mount Olive?
Yes. Yeah. So this is my first year participating, and one of the tasks involves the endurance. So this leads to my question: have you been involved in any other great discoveries, and if so, what?
Oh yes, in plenty one. I have been involved in several discoveries, major discoveries. I don't know if you know the author of the famous book, which is the most book sell over the world, called The Little Prince. His author it's a French aircraft pilot called Antoine de Saint-Exupéry. He wrote the book in New York during the war, World War II, and I discovered his aircraft in France. Then I have been involved in several, in fact, in all civil aviation crash in ultra deep water since 2000, which including the famous AF447, which was from Rio, Brazil to Paris, France. As well on the loss of the MH370, which has been lost on the coast of Australia. I have discovered as well and salvage, as I mentioned in my introduction, the city of Cairo. City of Cairo is the deepest cargo never recovered in the world at 5,200 meter depths. We recover 100 tons of silver coins with EUV that we send back to UK to the Queen. We discovered as well submarine that was been launched by Argentina, the Ara San Juan. We discovered as well another submarine lost in France in 1968 called Minerve. And all of these discovery is mainly made by AUVs and ROVs systems. So I'm quite specialized to be involved on projects like this since 30 years.
All right, great question. I would encourage any students who are interested to look up the City of Cairo wreck and read some more about it, because it's a fascinating story, and what Nico and his colleagues found was really interesting. HMS Seabots, thank you so much for those great questions. I'm going to bring in the Mount Olive High School and give you a chance to ask some more questions if you have something else you'd like to ask Nico.
Hello, thank you. We were wondering how you protected the tether under the ice. We know you talked about how at the ice level, but under the ice, once it was down there, how did you protect it?
Well, as soon as the tether was at 12-meter depths and it was free for any danger, because the angle of any tether when you dive deep is quite interesting, because it's going quite vertical immediately, and then you have some angle with the drag. So from 12-meter depths to the vertical, we got no protection at all, except the Kevlar, which is around the cable itself. Okay, so you have the fiber. Around the fiber, you have a Kevlar protection, which is breaking at 400 kilos, and then over that you have an outer sheet which protect everything in a single cable. So it was a single protection that the tether got from 12-meter depths to the vehicle itself.
Great question. Any other questions, Mount Olive? I'll give you a chance. Go ahead.
So we really, coming back to that sort of tether situation, we really liked how you brought in sort of novel solution you had, very specific to your mission. Were there any other interesting solutions you had to problems you encountered over the course of the Endurance mission? Something that maybe you haven't really experienced before or seen in the industry?
Sorry, I cannot hear you. Can you say it again?
So we really liked how you were talking about that very novel and new solution you had for that tether problem, trying to get it below the ice level. Were there any other interesting solutions you had to problems that you may not have experienced in different conditions, like not in Antarctica, when you're talking about doing your other surveying in open sea?
Okay, when you work in the industry, it's quite different, because as I mentioned in introduction, your vessel is slave to your vehicle. Okay, so there is plenty procedures which is oblige you to have the vessel at a position which protect your wire or your tether for a good launch and for a good operations. Most of the time you have to, we call that in the oil and gas industry walking the dog. Okay, so the vehicle is a dog, and you walk it with, sorry, it's like this is better. That you have the vessel like this, and you walk the dog. So the distance have to be identical, and you have to adjust this distance with the current, the drift, and the position of the tether when you do something which is in dynamic. Okay, because if you are with EUV on a subsea structure or wreck or something like that, you are in static. Your vessel is in dynamic positioning. Okay, and you have a straight line the seabed, to the vehicle, which is if it is a free swimming vehicle, or to the tether management system if you have a garage. But if you are, for example, doing a pipeline inspection, you are moving, and to protect your tether, you have special procedures which are the basic in the industry, to be sure that you will protect the propeller of the vessel, you will not put your wire on it, and all this protection, like the fishing float that we made here to protect from ice, are not used usually, because the position of the vessel is optimized to protect the vehicle and its wire.
Great, and I'll just add one more thing from my observations that I thought was simple but genius for how Nico and his team kept the ice away from the tether in the back of the ship. The Aeolus 2 just always sort of had its engine on just a little bit to keep the current moving back away from the ship, and that kept all free-floating pieces of ice that had been broken by the vessel out of that pool in the back of the ship, and kept the water open for the AUV to dive and surface, which I thought was simple and ingenious solution to that problem, because any one of those chunks of ice could have easily severed the tether. So thank you, Mount Olive. I know your team is the Loggerhead ROV team. I'm a big turtle fan, great team name. Awesome. Thanks so much for being here today. To end, I want to ask Nico one question from the chat that I thought was particularly relevant to this group. And that is, in your opinion, what can we do to encourage and engage children, teenagers, young adults to become more interested in underwater robotics? And who knows, have future engineers, people who are coming behind you and will be working with you on expeditions like this in the future?
It's fun, guys. Come in. No, walking offshore, it's a choice of life. And frankly, if you like that kind of life, do subsea activities. And I think that most probably the subsea activities is the last area of exploration that you have to do. It's everybody is aware that the surface of the ocean is a major part of our planet, and there is so much things to do, which is in industry, science, research, exploration. There is so much things to do. So if you are impatient to discover a new adventure life and new industry and new exploration, you have to go to subsea.
Fantastic. Nico, thank you so much for being here. Thank you for your time today and sharing your experiences and expertise. I'm going to bring our live cameras, students back on camera, so we can all sort of unmute and give you a big thanks and goodbye. Really appreciate it. Thank you so much, Nico. Thanks for everyone for joining us today.
Thank you so much. I really appreciate it. It has been a great time. Thank you, team. Thank you, kids. Thank you, all of you.